In this talk, kind of as I said here a few minutes ago, we're going to be talking primarily about things that you can do with your Visual C++ 6.0 installation to reduce your code size and increase your code speed. Now, you might be asking yourself, okay, so what is this all going to mean to me? In the end, it depends upon what kind of application you're writing, of course, but all the techniques that I'm going to show you here today are going to be techniques that you can apply to your different situations. For example, some of them, if you're using COM, will apply directly to them. Others will apply if you ever use a C runtime function at all, as well as even down to, how should I set the compiler and the linker to get the best out of it. So I'm hoping there will be something for everybody in the talk today. Don't be too concerned. I usually try to kind of explain these things from the ground up. So if you're kind of new to C++, hopefully everything should kind of fall in logical order. If you're an old hand at C++, hopefully I'll still be able to show you a couple things you didn't know before. For those of you who haven't met me, my name's Lon Fisher. I'm a developer with the Visual C++ team. And I've been at Microsoft, a little over 9 years now, coming up on 10. That means I'm older than dirt in Microsoft speaks. I've been there so long, it's, At Microsoft, they give you Ship It awards every time you ship a product. I think in all the time I've been there, I've shipped somewhere around 48 products, including all of the international versions. So, I've got these Ship It awards stacked across my office, all the ones that I've shipped. I started off working with MFC, and I worked on MFC from before version 1, for about a year before we made version 1, up through version 4. And then I worked on ATL from version 1 to version 3. And kind of what I do now is kind of high-performance web and enterprise development. So, optimizations and tuning are kind of things I'm very personally interested in, and I think a lot of developers are interested in as well. If there are 3 things I'd like you to take away, oh, by the way, welcome to TechEd. There are 3 things I'd like you to take away from today's talk is, first of all, little things mean a lot. Performance, surprisingly, it's always the small change that you make that gets you the big gain. And the thing I would have you take away from that is don't be afraid to try modifying things just a little to get that little extra performance. You might be surprised at how much that gets you. Small things make a big difference. Second thing, when you're doing performance optimization, this is really where Visual C++ shines. I mean, we let you do everything to everything, right? There's nothing you can't tweak with VC. And that's really good because the third thing I want you to take away is when you're designing an application, especially if you're try to focus on more of the theme of this conference, the internet, you got to think about the entire system to get the best possible performance. So you may have the tightest assembly code in the land, but your application still runs slow because there's a bottleneck somewhere else. So you always have to think about the entire system as a whole if you're going to get the best possible performance. Now, kind of what I'm going to do with this talk, I like to do kind of 2 demos with this talk. The first one I start off with in the beginning. What we're going to do is we're going to start with an app that I've already prepared, and you'll get this on your CDs. And we'll take a look at the app, and then we're going to start tearing it apart for the rest of the talk. And by the end, we'll keep your fingers crossed, have some pretty reasonable performance improvements, both in size and speed. So I'm going to start off just going to show you the app, and then I'm going to focus first of all on different things that you can do to reduce code size. Then I'm going to switch into things to increase your code speed, and I'm going to try to turn and tilt this a little bit more towards the web development angle, since that seems to be what obviously this conference is pushing, and also what a lot of customers tell me that they're working on. To finish up, we'll show you a modified version of that very same app, hopefully, again, running a lot faster, so you can compare and contrast the 2. Okay, what I've done is I concocted a very simple COM object on my system, and built with ATL. And by the way, a lot of people here hopefully a fair number of people, if they're coming for the STL, hopefully ATL is right up their alley. How many of you use an ATL? Good number? Okay, great. That way I won't have to go and explain all the innards. I'm going to start with a very simple ATL COM object, and it just has one interface and one method on that interface. And pretty much all that method is going to do is it's going to give us the account name with the highest account balance at a virtual bank, if you will. This bank is effectively a SQL Server database that's running locally on my machine here. So everything you'll see there is running locally on my laptop. And in effect, all it's going to do is it's going to scan through that database, give us the highest balance, return it back to the client. To begin with, if I did nothing, just ran the ATL wizard, built it with release min size, it'd be about 24 kilobytes size. Our implementation is going to use ADO to do our database work and then just some very basic programming to actually do the processing. Our implementation is actually that slide's a little bit wrong. It's a little bit about 73 kilobytes, partly because I switched system on here. It's about 73 kilobytes, and we'll take a look at the code. And actually, I think the code looks relatively straightforward. And then we'll start looking at making it better. So let me just go ahead and show you what this whole app does. Switch over here. Okay, what I'm going to do first is I'm just going to run the client portion of this, and I'm just going to run you through the implementation. So this is my MFC client. You can tell I put a lot of time into this. Okay. And it's got a button called Run, and when I click it, it runs out to my database and comes back with a name which is barfoo, and then a tick count. Now, the way I'm measuring performance here is with the getTickCount API, by the way. So I'll be using that throughout the talk. It's what I'm measuring. For those of you who don't know what the tick count, if you do a tick count when you start and a tick count when you stop and subtract them, it's the number of milliseconds. So if you were to translate this, it's 1,682 milliseconds for that particular run. Now, let me show you what the code looks like for this. And there we go. And what we're doing here, let me also show you the header file. That's important too. We're using the COM compiler support to import the ADO DLL. So we're just using the standard, Visual C++ COM compiler support. And once we've imported that, effectively the method here is find highest account balance. And I go ahead and I start off by doing a getTickCount. So we want to, that's the point we're going to start measuring. I then go through and connect up to the database. If you're curious, that connect looks something like this. And all this is a really fancy thing for, I'm looking at the pubs database on my local SQL Server installation. Okay. Now, what I do is I go ahead and I open up my record in that connect function. And then effectively what I do is I go through and I do while not end of file, I just move next, and whenever I find the highest value, I make it my maximum, and we go from there. In effect, once we find the maximum, it spits that out, or it spits the account of that out as the actual result. So in this case, it would be barfoo would be returned on this pbeaster name. That's an output parameter to this method up here. That's how the client gets that information. Additionally, we take a tick count at the very end of the function as well, and that we subtract the two and return the difference back to the client. So in effect, that's where the barfoo and the 1,682 milliseconds comes from. Basically, it passes all that back. So this is about, what, 20, 25 lines of code in there. Pretty simple. Open up a database, while not into file, move next, type application. Pretty straightforward, right? Well, Usually when I start tuning this, I can get somewhere between a 5 to 10 time performance increase in the code speed, and I usually will drop the code size by between a factor of 2 and 3. So by the time we're finished with this app, it should be far smaller and far lighter. Let's start talking about how we're going to do that. Let's see, preset. Hardest thing about this talk is this barcode up here. It's got rows upon rows of buttons. Before I get too much further, one thing I want to tell you is if you're looking for like general optimizations like loop reduction and things like that, your standard CS text is the best place to look. There's also a book out like called Optimizing Algorithms, and that's like was made way back in the 60s. See, if you look on Amazon for that, you might be able to find it. It may be out of print though. So your standard CS algorithm text is probably a good first place to look for that kind of information. Where I'm going to focus on, all the things we're going to do to this code are going to be based upon VC6. Now, let's start off by talking about how we're going to make this code size a little bit smaller. Remember how I said small things mean a lot? Well, one of the things that can add a lot to your code is what we call the C runtime startup code, or CRT startup. Basically what this code is, it's a large initialization block for the C runtime libraries, which contain a large number of different functions. Unfortunately, this code is about 25 kilobytes in size, and if you're doing a component you want to download over a low bandwidth connection, you might notice this. Because this is so annoying, or so annoyingly large, the ATL team, which prides itself on being able to do very small and tight servers, actually does some very tough love, if you will, to make sure you know about it and you can take appropriate measures. And then also, the compiler and linker switches can even affect this further. Now, let me ask you, how many of you have ever built an ATL project under release and you had this unresolved external thing show up? Yeah? That's that tough love I've been telling you about, right? This one, it's interesting. At Microsoft, we got a lot of guys with a lot of very strong opinions, and this one stuck. Basically this, we were arguing back and forth. Well, is it better to let them effectively double their code size for no reason, or should we tell them about it? And the tell them about it side won. So in effect, that's why whenever you build something, you get this unresolved external main. It's basically the decision that we wanted to warn you that the C runtime startup code is in your app. Now, we only do this in the release builds. And basically what that means is you do debug, everything works fine, and all of a sudden you get this unresolved external when you try to build release. Now, there are a couple ways to get rid of this. The simple fix is to go into your project settings dialog and remove ATL min CRT. Now, that effectively is going to basically turn off all the minimalization options for your ATL project, but it will allow you to go ahead and build that correctly. Obviously, you're going to eat the 25 kilobytes in code size if you do that. Now, the better way is to actually figure out what's making you eat that 25 kilobytes and get rid of it. Now, there are two ways to do this. My favorite way is to have the compiler specifically remove the libcmt.lib. That's the C runtime multi-threaded library. When you do this, all of your hits into excuse me, all of your hits into that library will come up as unresolved externals. At that point, you'll probably have a list of around 5 to 10 unresolved externals. You start looking at each of these, and eventually, either by trial or error or by previous experience, you will figure out which one or ones are causing you the problem. At that point, you modify the source code and you get rid of the problem. Now, there's another way to do this, which is to basically tell the linker to switch on its verbose, print out everything that the linker is doing. The problem with this, it works, but you have to look through sometimes about a 2 megabyte text file to find what you're looking for. So, if you're really, if you're getting paid by the hour, you're just totally bored, go for it. But I like to do the ignore libcmt, and effectively what you do is you can go into the project settings dialog, and just where it allows you to type things in directly, just do /nod:/libcmt.lib. Just type it in there, click OK, build it, and it'll give it to you. Now, obviously, once you get this figured out, you're going to want to pull that back out, right? So we'll go ahead and link in the CRT runtime. Now, not everything brings in this startup code. Generally, what brings in this startup code are the more complex functions. For example, the simple memory functions don't bring in the C runtime startup. The simple string manipulation functions don't bring in the C runtime startup. But the more complex mathematical routines, the more complex string manipulation functions all bring in this code. To give you an example, I do a demo every now and then where I use the square root function. That one adds actually 50K, 25K for math and 25K for the C runtime startup. So, when little things mean a lot, calling one little function can suddenly increase the size of your code significantly. Now, once you've figured out which function is causing the trouble, what do you do? Well, it turns out that the C runtimes aren't the only set of libraries in town. There's these other things called Windows libraries. Believe it or not, they often have pretty equivalent functionality. Take a look at the example there on top, the sprintf. Sprintf is one of those functions that just happens to bring in the C runtime startup code. It's fairly complex because it has to do all this formatting and other such fun. Now, look at the function below, wsprintf. That's a Windows library function, does not have the same problem. The difference of the letter W can basically save you 25 kilobytes. Now, I'm being a little bit unfair because there are some things that the wsprintf doesn't handle that the sprintf does. But suffice to say, for a lot of the cases that you'll find, you're going to find that a very simple change of code will be able to solve the problem. Generally, what I like to do is two things. I first like to take a look through the Windows library to see if there's something equivalent, if I can use that. And if I can't, is there an approximation or a slightly different algorithm I can concoct to get me around that problem? The end result is, if you're doing, just a second, if you're doing trying to do a very small, tight app, can be pretty large. It's a question over there. Right. The question was, does swprintf also fall into that? Yes, it does. It's pretty much the way to think about it for the string functions. Both the ANSI and wide character variants will both fall into those categories. So if it happens for ANSI, it will happen for Unicode and vice versa. So remember, little things can make a very big difference. Now, it turns out that's not the only way to get the C runtime libraries. Sometimes features that we all know and love as C++ programmers cost us. A lot of guys like to program with exceptions. For example, a lot of people think that's a really good way to do it, and it does have a lot of advantages in that you can put one big catch block, and pretty much handle all of your errors. The problem is with that is that that does bring in that 25 kilobytes of startup code. Additionally, features like runtime type information bring in the C runtime startup code. Now, if you've ever wondered why ATL doesn't throw exceptions, it's because of this fact. It's because that it adds that 25 kilobyte of code. We would much rather you go yourself and put on a try-catch block around our code and make the conscious decision to bring in that runtime startup code rather than having us force you to do that. So that's one of the big programming differences between ATL and MFC. Now, if you want to use exceptions, one thing you can do is to use structured exception handling from Windows. which can get you around the problem and still give you the functionality of exception handling. Other than that, maybe you just don't use the exceptions. You check your return codes, you check your H results, and go from that route. Just a second. I don't want to get in, I don't want to tell people that using exception handling is bad or wrong, because there's a lot of cases where it's really, really great. But just be aware, kind of as the old saying, nothing in life is free. There's a question here.
Sorry, this is one of the reasons I wanted to go to the other talk. The STL class is still exceptions. And at least in Microsoft's version of the STL, you have to turn that on.
Right.
How do you get around that?
Right. And and this is one of those very bad things. The question was, if you're using STL always throws exceptions, and you're pretty much forced, if you're going to use these things, to turn on the GX switch to enable the exception handling. What do? Well, that's pretty much, if you've got a great STL class that you just, it's just, you love it, you're using it, vectors, queues, whatever, then go ahead and eat 25K. That's pretty much all I can tell you. Unless you really are desperate, in which case you go back and rewrite the whole thing with structured exception handling. I doubt you want to mess with that. Right. Yeah, and if you can get a version of STL that doesn't use exception handling, and get that to compile and work correctly, that obviously is okay. One caveat about that, getting the STL stuff to compile correctly is a somewhat difficult process.
The gentleman that wrote the Visual C STL class,
Right.
he actually has a release. His next version does not use exceptions.
Mm-hmm.
I don't think there's any plans for Microsoft to license that version and fold it in.
I don't know personally whether we're going to have that or not, but I could definitely find that out for you. So the question is whether or not we're going to license another version of STL. We do look at these things. I just don't know for sure whether we're going to do that particular one or not. Let me step forward a little bit and talk about compiler and linker switches. Now, if you're like me, you look through all these compiler and linker switches, and very rapidly you're totally confused. You have no idea, boy, who came up with this stuff? The compiler has more switches than you can possibly remember. But then there are these pretty standard ones, O1 and O2, for optimization. One says maximize speed, the other one says minimize size. Which one should I use? Well, normally you would think it'd be pretty straightforward. If I wanted faster code, I would use maximize speed. Well, it turns out the Windows group actually went through, they rebuilt all of Windows that did no changes. They built one with O1, one with O2. Guess which one came out faster? Don't look at the slides. The minimized size. It's just very, very surprising. The reason, though, they went back through and they took a look. They started examining that, and basically the difference is the minimized size removes code, and obviously the less code you're executing, the faster it is. So even though the optimizations for O2 were trying to make it run faster, in the end, minimized size was faster. So the next time you take a look at your optimizations, think to yourself it's backwards. The smaller is better. The other great thing about the O1 and the minimized size is that it also forces the linker to turn on two switches for opt-reft and opt-ICF. Now, basically what those things do is it tells the linker to remove any unused functions or members. So if you've got code in your application that isn't getting called, the linker will just go through, rip it out. The ICF also works is especially useful for C++ functions as they get wrapped in a package which we also call a comdat. And effectively what that reference or that optimization tells it to do is to just go through, yank those things out of there. Now, by default, if you're doing debug builds, these will never be turned on. For release, they're usually turned on because of O1 but not necessarily O2. So that can also be a very useful thing in terms of removing code size. Obviously, if you're not calling function, it's just dead weight. If you're not using a member, it's dead weight. And the linker can adjust to make sure all the code still works correctly. The question is, how do you do that with the DLL? Generally, with the DLL, if there are generally with the DLL, if it's not used, if there's just paths and functions that are just unreachable, just not going to be called, it'll do that. It doesn't quite get as aggressive about doing it within the confines of a DLL. Right. If it's exported, but if it's not exported, then it's fair game. But there's one more caveat, obviously, in that it does have to check to see the export. Now, how many of you have ever written a COM object? Have you guys used an ATL? Why don't you even ask that question? You've all written COM objects. Yeah, okay, fine. You know that little IDL file in there? You know, that little interface description language file, the one we keep telling you we're going to get rid of every version, you know, and we never quite do it? Yeah, okay. Well, that IDL file, I don't know how many of you really have ever taken a chance to go through and really understand what it does. I'll actually talk about this some more as we get to the code speed and marshalling section. But effectively, what that IDL file compiles into is a proxy stub for you. And what that allows is for a caller to pass parameters and to get return values from your function, whether that be in process, out of process, or on a remote machine. Now, it turns out, normally as C++ guys, we're kind of taught, you know, compilation is better. Compiled is good. Well, it turns out that with IDL, this is probably the exception to the rule. Now, with IDL, there's a switch on there called OICF. Now, effectively what that switch does is it tells the proxy stub generator, middle, to generate code for an interpreted marshaller. In other words, it's going to figure it out at runtime. Now, normally, you know, we kind of sit there and kind of, you know, wrinkle our noses at that, going, ooh, that's going to be slow. But it turns out, believe it or not, these guys did a great job of it. These guys did such a fantastic job of it that it's basically right there with the compiled version. The difference is that the interpreted version has a lot less code. So if you're doing a COM object, turn on that OICF switch, your code size will usually drop by a couple of additional kilobytes just because of that. Now, additionally, if you're doing MTS programming or COM plus transaction programming, they'll actually force you to turn on that OICF switch because they need to be able to get into that interpreted marshalling section themselves. They need to be able to twiggle with some statements going on in there. So if you're doing MTS, you're going to get this for free. But if you're just doing a standard COM object, usually that standard interpreted proxy stub is going to give you the best overall size while giving you really good speed. It's a question here. Yeah, the question is, aren't you just loading another DLL which is going to do the interpretation? Yeah, you're going to do that the first time, and you're going to bring that in with you. Now, this question here. The question was, does that affect the default marshaller for OLE automation? No, it doesn't. It's actually a separate marshalling thing, which I'll call standard marshalling, as opposed to automation marshalling. Now, all of you using ATL use a lot of templates. Templates are, you know, templates can be really handy. I myself is a big convert when I moved over to the ATL team, just how much templates could, you know, if used properly, could really make your code smaller, tighter, and better. There is, however, a downside to that, and that is if you're a little bit careless, maybe not even obviously so, your templates can come back to haunt you. In effect, the compiler will go as far as to generate multiple instances of template functions based upon the instances of the template class itself. So what that means is, say I make 2 instances of a template class, rather than the linker just having one function that it calls over and over, you get 2 separate functions doubling your code size, right? Imagine making 20 instances of this, 20 copies of your function in your compiled into your code. The reasons for this aren't always obvious, but there are some things that we can do to get rid of that. The way we do that is with a tool called MapCat. Now, MapCat's a little internal Microsoft homebrew type tool that we release out at conferences. And basically what this thing will do is it will go through the map files that you generate with your linker, and it will go in and take that information and put it into a CSV format that you can use with Excel. With Excel, it's pretty easy to find when you've got these duplicate functions with templates. And by figuring out the cause of that, you can really reduce your code size. It also will tell you why we use all these base classes in ATL, if you've ever seen these little base classes running around. Let me switch over, show you a little demo of this. Preset 5. Now, let me make sure I bring up a DOS box here. And we'll do this. Now, what I'm going to do here is I've got a directory here, and I've got a file called bigmap.cpp. Now, I've already created a couple classes here, and as you can see, I've removed all the bugs from from cfoo1. Okay, so no bugs in there whatsoever. Now, effectively, all this thing is going to do is it's 2 simple classes. The difference is one has an integer, one doesn't. And then we're going to use a class cbar that derives from the template derives from a templated class called t. And this particular class has an integer and then a function called do something. And then finally a little main thing here. And what it does is it makes a template instance of cbar using cfoo1 and cfoo2, and then for each one calls that function. Okay? Fairly simple app. Believe it or not, when we compile this, the compiler is going to create 2 versions of do something. One for B1 and one for B2. Even though it's only setting B equals to 5. Let me show you how you figure this out. Now, what I'm going to do is I'm going to go over to, okay, all right. Oh, no space, sorry. My directory here. Now, I've already got MapCat installed here. Let me make this a little bigger for you so you can see it. There you go. I've already got the MapCat tool here, and this is also the directory where I have my CPP file. What I'm going to do is I'm going to go ahead and compile this just to an OBJ file. And it helps if you do, brother. Let's see, is it in here? There. There. Warning, coding in front of the audience could be hazardous to your health. So what I've done here is I've compiled the bigmap.cpp into an OBJ file. Now what I'm going to do is I'm going to take that OBJ file and link it. But I'm going to specify that I want a map, and we'll call that bigmap.map. And we'll use the OBJ file we just created. We link that, and so now we have bigmap.map, and now we run that MapCat tool on it. As MapCat sounds, it takes a map file in and it spits a cat file out. And now we have this cat file. What you do now is you run Excel. Excel is a good tool for this, but pretty much any spreadsheet program will be able to handle this. You open up that file, and let's see. And what it's going to do is it's going to say, okay, you've got tab delimited information, or tab delimited information on here. Do you want to go ahead and import it? If you just take the default, it's going to bring it in. Now, thing here, all this is going to look like big-time gobbledygook, right? And this is effectively all the output of the linker using all of the name mangling. But you can figure out some stuff fairly quickly. Take a look at do something. There are two instances of those. One for the instance B1, one for the instance B2. Sounds kind of interesting. Why do I need two instances if I'm just setting B equals to 5? Well, it turns out, let's take a look at our code again. I'm inheriting from this public templated class. One of those has an integer, one of those doesn't. Then notice that in my class C bar, I've got an integer B. Now, when I inherit from class C foo1, the vtable address for the member variable B is one location. But when I do the other one, it's now at a different location because integer A will come in before that. Remember from C++ that your base classes members will always come first in that vtable. So in effect now, B equals 5 means two different things, one for each instance. That doesn't sound very good, does it? So a very small thing has actually duplicated our code. Well, now, how do we get around this thing? Let me just select all of this. I'll just do a new file, copy it in. Well, the way we get around this, and this will explain to you why we have these base classes in ATL, we come up with a class C bar base. And in that, we have a public int B, and that's it. Let me save this for map.cpp. There you go. Now, what we do here is we inherit from C bar base first, before that templated class, and then we remove B from C bar. Now look what's happening. The bar base, the integer B, is now always going to be at the same location. It's going to come first in the inheritance, so it's always going to be at the same vtable. Let me save this. And we'll go ahead and compile it. We'll do the same thing that we did before. And then we'll run mapcat again. And we'll go and load it into Excel. And again, we'll hit finish. And now, if you take a look, there's still two instances, but notice the size over in this column for one of them is now 0. In effect, what's happened is because that vtable is the same, the linker has come along and said, oh, okay, I only need the one instance. I don't need to generate any bytes for the other one because they're all the same place. The first application, we had 53 bytes just for one function. The second one, we had 20 bytes. So if you ever look through ATL, you see these base classes. That's generally things that we're doing. We're looking out, see if there's any member variables, as well as commonly used code that can be brought in first. This alone, taking a look at this with mapcat, just run it over your templated application. Take a look at your own classes. It's a great indicator if you're doing something wrong. Again, you'll get that on your post-conference CD. Some other interesting things you can do with it, you can dump this information into a pivot table if you ever want to take a look at the analysis of this data, and that can tell you how big classes are. The one caveat with this particular tool is not so great around page boundaries. So if you see a function that just looks absurdly large, what's happened is the linker has put it at the end of a page segment, and all Mapcat does is it looks at the address, the next address and the function address, subtracts the two, and that's the size. So whenever you see that, it's got that page boundary in there. So that's the one caveat. But for other than that, it should be able to give you a lot of useful information. Okay. Now, so I've talked a little bit about code size, and I've tried to focus there kind of on the things that you can use. But to be perfectly honest, code size is very relative term. If you're doing a low bandwidth download, it's really important to you. But if all your customers have 2 megabit per second DSL, well, okay, maybe it isn't. So maybe the code size needs to be bigger. So depending on whether you're interested in 25 kilobytes or whether you're interested in, oh gosh, this template's just generated 3 whole megabytes of code, hopefully those techniques will be able to give you some information. The compiler switches, though, the more code that you're writing, that minimized size window is really useful. Now, let me kind of switch over to the flip side of that, the code size. Let's talk about code speed. Now, obviously, I was talking about the standard CS algorithm optimization earlier, but there's a lot of things that go on within the confines of Visual C++, COM, data transfer, you name it. There's a number of things that can just go wrong there and just thoroughly mess you up. Let me first talk about threading issues. COM, as any of you have ever read Don Box's one of his books or taken one of his courses or learned anything about COM threading, basically what happens is that at the heart of COM is the need to transfer data between the caller and the callee. Now, the thing about COM is that the location of that particular object may or may not be in your process. In other words, this pointer may not be, the heap pointer may not be the same for both the server and the client. In fact, that server can be sitting on some remote machine if you want to. So at the heart of all this is, how do I get data from point A to point B? And in COM speak, we call that marshalling. Now, there are a number of different types of marshalling that can come into play. The one that we'll deal with on the threading is whether or not you're crossing apartment bounds or potentially, and then there are other kinds, I should say, that you potentially have process and machine boundaries. Now, there are 3 different types of marshalling that you generally get to use with COM. You have the standard automation, which somebody asked me earlier about, and that's for the iDispatch interface, or OLE automation for short. I've got a really funny story about that, but about the creation of dispatch and automation in general. But it's basically Bill looked down upon the world and saw OLE automation, and or excuse me, in the beginning there was COM, and Bill looked down upon the world and said all was good. Then the VB team came along, created OLE automation. Bill came back, looked at it, and said, "Geez, this sucks." And then the VB team said, "Oh, let's merge the two together and have a dual interface." And we said, "Okay, we'll settle for it." So I'm full of jokes like this. My girlfriend tells me I should not be a stand-up comedian. I think she's wrong personally. I think But anyway, the OLE automation again is that standard. The standard iDispatch, and that's the variant data types, beasters, simple fixed data types, that type of information. That's generally used whenever you're going through the iDispatch invoke method call. That's very, very slow. And if you ever want to know why, take a look at MFC's implementation of iDispatch. I think there's like a couple thousand lines of code to handle all this stuff. This question there. Right. Right. So there's a slight difference to that, which I'll call standard automation. The question is that whether you can use type libs for automation marshaling or for what I call middle generated marshaling. I'll get to that. Just a second. Now, believe it or not, if you're ever interested in another little story, 2 days before we shipped MFC 1.5, which was the first version of Olay, we realized that we had reversed the order of all the parameters in every Olay automation call. That is really funny. We found this about 4 a.m. in the morning. We were very unhappy. The second type of marshaling is called the standard marshaler, and this is generally what almost everybody uses. Probably 90+% of you will use this, most of it without even thinking about it. Now, generally what this thing does is it's generated by middle, and for most of the time, if you're using the simple fixed data types, that's how you get that interaction. Now, there are some things that you can do with this in your IDL file. It will also understand a little bit more complex data types. For example, if you've ever seen the size is declaration in IDL, size of, you can actually tell it how big a buffer it should have, how many bytes it needs to transfer when it sees one of these. So there's a number of different things that you can do with this. But in general, this type of marshaling is defined by, I write this up in my IDL file, I run the middle compiler on it, it generates me a proxy stub. Whether that's the interpreted with OICF or whether it's something I compile up myself. Now the third type is what we call custom marshaling. And this is for that last 1% of you who have very specific and unique needs. This is where you get to go in and implement iMarshal yourself. And you might do this because you've got a heck of a lot of data to move. You've got a lot of data that tends to remain the same, so maybe you want to cache somehow, you want to perform some sort of algorithmic processing on it. But it's generally for those people that have a lot of data to move back and forth between their COM client and their COM server. So generally speaking, the 90% case will probably be that standard marshaling. Now, the threading also comes into play. With COM, there's always this concept of are you single-threaded, free-threaded, or what? Now, with COM, there are 4, and then there's sort of a 5th type now called rental. We ain't allowed to add these things. And basically, this is for DLLs. This is specified in the system registry by the threading model key. The single, I'm single-threaded, basically, and that means that only one person can call into me at one given time. And in effect, anybody, if 2 or more people try to call into me, then what COM will do is it will stick in this queue, and it will go ahead and basically only call one guy at a time. The second one is, or the second type, is apartment model, and that one is mainly used for controls controls displaying a user interface, for which they can only really allow one person to modify a particular thing at a time. So the example I like to give is if I had an active control and it had a font in it, and I had multiple people trying to change the font for their own individual needs, well, who wins, right? What you really want is for each person or each caller to have its own individual view, or apartment, if you will, that each contains its own individual font. And that way, I use Lucidia, somebody else uses sans serif or whatever, and everything stays the same. Now, generally, the third type, both, is probably what I consider, if you're doing like non-UI based development, what you should use. Now, what happens here is it depends upon who's calling you. If your client is single-threaded, you as the server will also be single-threaded. And what this means is it won't necessarily have to marshal stuff across apartments to get to you. Effectively, you'll both be put into the same apartment. You'll both be able to basically talk directly to each other. If, on the other hand, your client is multi-threaded and basically uses co-initialize EX and then calls into you, you'll be created in a multi-threaded apartment. Again, the same thing applies. Where you run into trouble with COM, and this is what eats your performance, is when you're a single-threaded guy and the guy marks himself as free-threaded, or vice versa. You're a multi-threaded guy and this guy marks himself as a single-threaded type. What happens there is COM steps in for you and decides to become a traffic cop. COM basically takes the lowest common denominator, who's ever the single thread case, and basically fits a queue around it, and effectively only lets one call go through at a time. This can also cause you to have to marshal your data across departments. In effect, that marshaling code gets invoked. Now, ideally, what you want is it to be in your same process, in your same apartment. It's just a direct function call, right? But if it's across an apartment, COM may have to go through and marshal stuff for you. That slows you down. Now, how do you get around this? If you're writing a server, I like to just think of two simple rules. If you have a UI, select the apartment model. If you don't have a UI, select both. In effect, whatever client calls into you, you will appear to them as the correct type, whether you're in a single-threaded apartment or a multi-threaded apartment. Now, there's another one out there called a rental model, which is this kind of like, it's one step closer to free-threaded than the apartment model. And that one is has its own unique kind of things. I haven't seen many people using it yet, though. So in effect, kind of use, for right now, I would say apartment or both. Now, there's one thing there with the both. There's one caveat. If you've ever run the ATL wizard, you'll see this little checkbox in there that says aggregate free-threaded marshaller. You ever wonder what that thing does? Well, what this thing does is it will go ahead and it will call into some COM APIs, and what it allows you to do is it will save you the scenario where you hand a pointer to yourself, in other words, an unknown pointer, to somebody in another apartment. You may not know they're in another apartment, but they are. But you're both in the same process. So in other words, I have one XE, I have one client that's in one apartment, and it's calling into my server that's in another apartment. My server hands it back an unknown pointer to itself and says, here, have fun. What happens is the free-threaded marshaller steps in and says, oh, wait a minute, you guys are both in the same process. You know, we really don't have to marshal any data here. We could just do a direct function call. Wow, let's go ahead and do that. Both have the same heap pointer, everything's the same, go for it. In effect, you're turning a case where you would have had to marshal before into a case where it becomes a no-op, in effect, a direct function call. So by aggregating on that, if you are the kind of person in a method that likes to hand a pointer back to an interface or whatever, that can really save you some time. Now, generally speaking, you say, well, how does this kind of manifest itself in performance speak? Well, what happens is, as you keep running this over and over and over again, when you start having these different threading model issues, it starts to slow you down, especially the more weight you try to put on the server. For those of you who were in my talk this morning, I talked about if you're doing like an MFC web app, one of the things you want to make sure is that if your app is multi-threaded, your database driver should be as well. And for example, like in OLADB or ADO, if you use something that's not listed as both, and you're a multi-threaded web server, you call into that guy, every call you make into it's going to go through effectively a queue, which is about the worst thing you can do when you're under a very high availability or a high performance situation. In effect, it's like somebody standing up with a stop sign, letting one guy go through at a time. So that can really, really cause you problems. Now, some of the other things, this kind of builds on top of the marshaling. Data transfer. beware of strings. You know, hey, strings are our friends, right? You know, we use them all over the place so we can read stuff, you know? But turns out there's a couple things you can do with strings that'll just eat you alive. First of all, I hate beasters, to be honest. Anybody ever asks me, I hate beasters. I mean, first of all, how many ways do we really need to display a string anyway, you know? But beasters can be especially bad for a couple of reasons. First of all, beasters are all Unicode. If you're an ANSI, guess what? You're going to go to get converted to Unicode automatically. That takes time. Furthermore, if your client's also ANSI, before it comes back, it'll get converted from Unicode back to ANSI. Was this trip really necessary, right? So you're effectively doing two conversions when you don't really need to. Now, the other side of that is a beaster has its own memory. So guess what's going to happen? When you do this, you're going to get malloc or something equivalent called. So you have another memory allocation. It's going to hit your working set too. Now, to be perfectly honest, if you're passing a beaster in a method, you're passing one beaster or even 10 or 20 beasters, it's not going to make a big difference. But when you start passing thousands of beasters, a good example of this is you're reading a database and you're sending strings back, and they're all coming back as beasters. You are going to start to notice it, right? Now, in general, in the case where you know whether you're ANSI or Unicode, you know what you want, you might think about using something that transfers the data natively. In other words, don't perform the conversions. Just give me the string. If you're interested in that, then ODBC or the OLADB consumer templates could be useful for that. The reason both of these are useful is they don't have the dreaded variant. Whenever you see a variant and a string is nearby, that variant will latch on to it, gobble it up, and form it into a beaster. That's evil. Ugh, I hate variants. I really hate them. Well, hey, you wonder why, Now, there are some other things, and here I'm going to focus more into the enterprise side, because remember I was telling you it's a system. So if you're doing like a website or something, you probably got a database hooked on there. Now, if you screw this up, it'll also hit your performance. Basically, you might have a really fast middle tier component, but your database side, you're trying to get data just taken forever. One thing that can happen is you don't handle your connections right. Generally speaking, you want to know how many connections you're going to need. And you can do this one of two ways. One way I don't show you here is to allocate a fixed number of connections and stick with it and always reuse them. You can certainly do that. In effect, you're creating your own static pool. Now, if you don't do that, then effectively what you want to do is use the built-in system pooling options. And the way this will manifest itself is when you're using your code, you want to use a database connection and lose it as fast as possible. The reason is, while you're using that connection, nobody else can. So if you hang on to this connection, put it in your pocket, and you're just kind of partying along doing stuff, some other guy is sitting there, he's looking for a connection, there's none available, so gasp, he has to go out and create one. In effect, over time, the number of connections you have open keeps increasing and your performance keeps decreasing because you're putting more and more usage on the database. Now, this is actually somewhat maybe contrary to what we're used to with C++. We're told that, hey, member variables, tuck it in there for the lifetime of the class, yeah, good to go. With high performance, like especially enterprise, that's actually a bad thing to do because you want to very carefully control the lifetime of your connection. So in effect, you want to open a connection and then close it immediately. Now, the reason this all works is because both ODBC and OLADB WAC-ADO have pooling mechanisms underneath them. What will happen is you come along, you ask for a database connection, it gives it to you, and the first time, and it creates it from scratch. You go ahead and you use it, and then you disregard it, you close it. But it isn't actually closed. what happens is it gets returned to a pool, and that pool only gets closed out when your application shuts down. The next guy that comes along asks for that connection with the exact same connection information, in other words, the same user ID, same password, so on and so forth, grabs it out of the pool. It's already open, it just hands it to him, ready to go. So in effect, just a second there, in effect, you're not really deleting the connection, you're just allowing it to transfer ownership much more easily. Now obviously if two people come along at the same time and both want connections and there's only one available in the pool, then that second guy will create a new one from scratch, but then they'll both go back into the pool. The nice thing about this is it allows you to hand your connection over to other people very quickly. There's a question back there. I want to, okay.
How do you hand back something to VB without a booster?
Okay, and I'll kind of go back and restate something I said. The question was, hey, how do you hand something to VB if you can't do a beaster? And this actually kind of comes into probably the next slide as well. What what I was alluding to is, passing a few beasters isn't necessarily bad, but it's when you're transferring tons of them that really make the difference. And what I would suggest there is you take a look at how much data you're going to be sending across to VB and say, well, can I maybe do this a bit different way so I don't have to transfer so much data? Yeah, I mean, VB needs a beaster, right? Variants are us is VB, right? Question in the back. Right. Okay, so I didn't quite catch all the second sentence. Right. All these connections are not. Oh, each of the. Okay, I'm sorry. If you have 10 separate users, and all of the users are different, then of course the pool will not be able to satisfy the request. It'll have to go in and do that, create a new one for each one. But there's a little trick you can do to get around this. In the talk I did this morning, which is it was basically MFCI SAPI talk, one of the things I talked about was impersonation. If you impersonate a singular user on there, then that user effectively gets that type of information. Now, additionally, there's another way to do that as well. For example, with SQL Server, you can either use a Windows authentication, so in other words, who am I logged in as, or you can use a system login as well. So there are a couple ways to do that. But what you effectively want to do on your website is have only one set of connection information, whether that I'm hooking up as user SA, or I want to impersonate somebody who's always going to have the same credentials. So rather than letting whoever, Joe and Ed and Mary and whatever come in and try to create their own connections, you basically force them down into, oh, you're going to just for the time being use my connection, and that's how you keep that out of that pool situation. Couple things, then I'm going to show you the finished part of this demo. This is kind of my next part of this, the thing and the person who asked me about what about beasters and VB. One of the main things I like to do here is talk about how much data you're really transferring. Now, look in the initial implementation of that app, we went through and just did while not end of file, move next. There are 50,000 records in that database. So that meant we transferred 50,000 things across the wire. One of those is a string, so we passed 50,000 beasters while we were going, right? Do we really need to transfer all those? Well, chances are, then we can take a look and see where we can do the work better. In the case where we're doing the database, what about using a stored procedure? For example, let the server figure out who the highest account balance is, and just return us that singular person who has that title. In effect, why transfer 50,000 records when you can transfer 1 or 10 or some small amount? In effect, stored procedures can help you structure your application in terms of how much data you want to transfer from point A to point B. Because of this, that can dramatically impact your performance, especially if you're, if you're going from something like 50,000 or 100,000 records down to just a small number. Let's see. What I'm going to do here is I'm going to switch over my demo, and I'm going to show you the finished demo. And then I'll talk just very briefly about indexes, and then I'll wrap up. Okay. Now, what I'm going to do is I've got my updated project here. Now, this is the same piece of code we had before, with a couple, or with one exception. Let's see, here we go. So I'm going into, I don't want that, I want you. I'm going into my method again. I still do my tick count, but here, instead of going through and calling for all of the different records, instead, what I'm doing is I'm using a stored procedure this time called SP highest balance. Now, sitting on my machine is a stored procedure that effectively will return me the same information as I had before, but only if it's equal to the maximum account balance. So in effect, SQL Server is doing the work here. And if you want to see the stored procedure, I can show it to you here in a little bit. What we're doing now is we're only passing, in this case, we passed down 2 rows. There's actually 2 people that have the same balance on this particular database. But what I do is I just move first, and because I know the stored procedure's already done the work for me, I pretty much finish up. So 50,000 records, 2 records. 50,000? 2, okay. You would think that this one would be a little bit faster. Now, the original app also had try-catch blocks in it, in the connection for ADO. What I've done here is I've switched over to OLADB, in this case the OLADB consumer templates, which again is a stored procedure. And for those of you who aren't familiar with the OLADB consumer templates, they're basically ATL's database template classes, if you will. The nice thing about them is that I can request a tchar, and since I'm building an ANSI, it'll basically turn into a character buffer. So rather than having a beaster where I have to do 2 conversions, I only have to do, I don't have to do any conversions, and I just get the data directly. So I'm kind of passing that up as well. To get back to the try-catch block, because I don't have that try-catch in there anymore, I don't need GX turned on. So I don't require all of the exception handling, and I don't require that 25 kilobytes of startup code. Now, additionally, I'm building my release min size. Let me build this guy. And let's see, where did I put you? I think you're in here. Oh. Okay, drum roll. 28. So I removed the ADO in favor of OLADB, basically for the removal of the exceptions, and then I use a stored procedure instead of the moving all the 50,000 rows down, and I dropped it by 73 to 28, 45 kilobytes, somewhere in there. Now, so that's built, and let me go over to my client. And I'll run this a couple times. I hope this is all working. It'll take a couple times for it to get warmed up. So about 260 milliseconds for that same thing. So now remember, all this is running locally on my database. So the transfer of those 50,000 records isn't quite as painful as if they are over a network, right? But even with that, that's about a 5x improvement, somewhere in there, a little over 5x. So just changing a couple of things, first of all, thinking about how we're doing it, thinking about what we're doing, and then as well as thinking about how much code we're bringing in, how we're transferring data, can really make a large difference to us. Now, there's some things I can do even beyond this to even get better performance. And this, again, is kind of in the context of that enterprise. And that's for the, wow, that's cool. And that's for, in terms of tuning the database itself. I haven't gone through and done any work here to tune the database. And that's probably, I'm sure there's probably about 30 SQL Server guys at the conference can tell you how to tune it. And if they don't, I can. But basically, what you do is you can go through and assign an index onto the tables that you're fetching from. So in other words, an index effectively acts like a lookup table where I've already sorted all of the information I'm looking for. So in this case, instead of having to have the server, the database server, go through all 50,000 records to figure out which one is the best, it can actually already have a table, and it can go, oh, I want the max. I should just start at the end and grab it and come back. So that will even indeed be faster. To give you an idea, on some about 4 million record databases, without an index, it would run between 40 and 60 seconds. With an index, it would run about 150 milliseconds. Okay? That's obviously a well-tuned index, but if you don't use an index on your database, and it's a fair number of records, fairly large records, you're really probably losing some performance there. Some other things that you can do are to actually take a look at the stored procedure. The stored procedure itself, is it doing a good job at fetching the data? Is it maybe doing a really complicated join operation that you don't need to do? Usually, simple is better, believe it or not, especially when you have a lot of people pounding on your database at the same time. We found that if you have a very complex stored procedure, while it might be a little bit more precise, perhaps, and like maybe I return 1 row instead of 10, the CPU utilization for the database can also be higher. So take that into account when you're doing you're looking at the queries. Beyond that, let me just kind of wrap up, because I know you guys want to get to Pure Talk. I think there's beer there. That's probably why. Little things mean a lot. And the point I made there is like the try-catch blocks. How some fairly simplistic things, they don't seem all that harmful, but boy, they get you. In my case, I used I told you about the square root function. I used it as 50K for one function. It's pretty pricey. Think about those things, especially if they're bringing in things like the C runtime startup code, and see how you can get rid of them. Second, some of the things we're taught as C++ developers kind of work against us. For example, like with database connections, using them and losing them as fast as possible. Let a pool handle it. In effect, let the guy do the work or let the next guy come in and do his work as quickly as possible. Never, ever hold on to a resource that somebody else can use. Of course, performance isn't just one of the unfortunate things I see a lot of people do is they get the program done, and then only at that point they start thinking, oh gosh, it's slow. What do I do? You got to think about performance from the get-go. How are these systems going to interact? Think about in your head, how much data am I transferring over? If my current design calls for me to download 2 million records from a database, and I could get away with less, hey, why not redesign it? Take advantage of some of that. Think about that from the get-go. Of course, there's plenty of good tools to help you as you go through. NewMega has all of their dev partner studio that can go through and help you with profiling, tell you if you're doing things bad. You can even use, heaven forbid, the Visual C++ profiler, the much maligned but very long-lived profiler. It still works. And that can tell you a lot about what you're doing. But check that performance from the start as opposed from the end. It'll be a lot easier trip. Last but not least, don't be afraid to experiment. That's the great thing about Visual C++. We let you tweak everything. A lot of times, people find things that, gosh, I didn't realize I could do that, and that saves me so much time simply because they experimented a little bit. A lot of good examples of that. In fact, a lot of parts of the talks that I give are often these little things where somebody asks me a question, and I've just gone through and said, wow, hey, that's kind of interesting. Maybe I'll tell somebody else about that. So don't be afraid to experiment. Try different techniques. I think you'll find that your code size reduces, your code speed will also improve. There's nothing better than watching your app just hum, because it's so finely tuned, you know it's great. So with that, thank you very much for coming. If you have any questions, I'm going to take probably just a couple of questions here, then I'm going to start kind of walking you guys down to pure talk. So they told me they would send the Marines in to get me afterwards.